this video, we will be discussing what is n factor and how to determine n factor in different cases. N factor is basically a conversion factor between molarity and normality. Molarity into n factor is basically normality. Now for different cases, we have to calculate the n factor. First case I am teaching you is for ions. If you have given any ion, for any ion, n factor will be simply charge of the ion. Charge of ion will be n factor. For example, Al3 plus, n factor will be 3. For example, Cl minus, n factor will be 2. Okay. Now for atoms, if we have some atoms, so here n factor will be basically, if the atom is from group 13 in periodic table, it is in group 13. For atoms, it is basically n factor will be simply valency. How you will get to know about valency? 1 minute. Okay. How you will get to know about valency? We know if we have that atom from group 13, that means boron, aluminum, gallium, indium, thallium, then n factor will be 3 because their valency is 3. Group 14, okay, then n factor is 4. Then group 15, that is nitrogen, phosphorus, that will have valency 3. Okay, next group 16, that means oxygen, sulfur, that has valency 2. Okay, now group 17, chlorine, fluorine, bromine, iodine, this is valency 1. Okay, so this is basically valency. This is for atoms. Next is salt. Mind it, for salt it is pretty much confusing. It is basically total number of positive charge in salt. Total number of positive charge in salt. For example, AlCl3. I have AlCl3 salt. What we have to do? First we have to dissociate it. Al3 plus 3Cl minus. Now this system has this cation with 3 positive charge. So n factor will be 3. Suppose ZnCl2, Zn2 plus 2Cl minus. Here n factor will be 2. For example, Ca3PO4 whole 2. Some people do not know how to make this dissociation. For a salt with composition AXBY, if you dissociate it, you will be getting X amount of A plus Y amount of B, but the charge will be the opposite. Like A will have charge Y positive, B will be charge X negative. So it will be the dissociation. From this concept, you can dissociate it. 3Ca 2 plus 2 PO4 3 minus. So total positive charge, it is basically positive portion. 1 Ca has 2 positive charge, so 3 Ca will have 2 into 3, 6 positive charge. So n factor will be 6. For example, K4 FeCN6, potassium ferrocyanide. So here 4K plus FeCN6 4 minus. So there are 4 cations with single positive charge. So overall n factor is 4. Right? Simple. Okay. Now we have discussed salt. Now we have to discuss polyatomic system. Polyatomic system. For example, we know oxygen has n factor 2 because oxygen is group 16 element. If it is given O2, then we have to add 2 plus 2, 4. Similarly, chlorine, we know n factor is 1 because halogen gas group 17. So Cl2 will be 1 plus 1, 2. So this is for polyatomic systems. Now, there are some other aspects to calculate n factor. For others, there are some other cases, and these are very much important. So last 3 cases of calculating n factor. First one is for acids, second one is for bases, third one is for redox systems. Redox systems. For acids, N factor is basically basicity of acids. Basicity means number of H plus that can be donated. That is number of H plus that can be donated. It is basically, it is called basicity of acids. For example, HCl. HCl is called monobasic acid because it can donate only one H plus. H plus plus Cl minus. So only one H plus can be donated. So here N factor will be 1. Suppose H2SO4. 2H plus plus SO4 double minus, right? So it will have N factor 2. But mind it, if in any reaction or any system, H2SO4, it is shown that it has dissociated like this, H plus plus HSO4 minus. It has not dissociated like 2H plus. Then in this case, if it is specifically mentioned, because here only one H plus is removed, second one is already is with this counterpart. So one H plus is removing. So in this case, H2SO4 N factor will be 1. In general, N factor will be 2. But if in any specific reaction they mention that only one H plus is getting removed, then N factor will be 1. Now, a very popular example, H3PO4, H3PO3, H3PO2. These three are very much popular example. For these three, we have to know their structures. H3PO4 phosphoric acid will have a structure like this, POH, OH, OH. Okay. But H3PO3, there is one oxygen less, so we have to remove this oxygen. For H3PO2, we have to remove this oxygen. Now, the oxygen, the hydrogen, which is directly connected to oxygen, will able to donate as H plus. So here, 3 hydrogen is available for donation, right? Because all are connected to oxygen. So here, N factor will be 3. But for H3PO3, the structure will be like this. But this hydrogen is not connected to oxygen, so this will not be donated. Only this hydrogen and this hydrogen will be donated as H plus. So it is, if it dissociate, then we will be getting H P double bond O minus plus 2H plus. Okay, so this hydrogen will never get dissociated. So 2H plus means N factor 2. Similarly here N factor will be 1. I think you have understood it. Now some more examples of acid, some more exceptional and unique example, you can say. H3BO3, this is called boric acid. It has actually 3 hydrogen. I am showing you typical examples where you can get confused. Okay, H3BO3, it will be 1 because H3BO3 actually it is BOH whole 3, and when it is with water, then it makes BOH whole 4 plus H plus. It is basically reaction. It is basically giving only one H plus. Okay. Okay. Now there are another kind of acid. Suppose it is given, for some example, for SO2 we have to calculate N factor. Now we know SO2, if it is added with water, then what will happen? H2SO3 will form. You just add up this H2SO3. H2SO3 means it will give 2H plus. So N factor is 2. So for SO2 N factor is 2, for H2SO3 is N factor 2. For SO3, similarly, if you add water, you will be getting H2SO4, sulfuric acid, and initially it was sulfurous acid. So here also you will get 2H plus, and then N factor will be 2. Right? Because SO2, when actually added with NaOH, then actually it reacts with H2SO3. So keep in mind these typical examples. For bases, similar concept is called acidity. Number of OH minus, how many OH minus a system can donate, that is called its acidity. Suppose NaOH, only one OH minus it can donate, Na plus OH minus, so N factor is 1. For CaOH whole 2, 2 OH minus can be donated, so 2. AlOH whole 3, it is basically 3. Okay, now one typical example for redox reaction. Okay, for redox reaction, be very careful. Okay, one more thing before the redox reaction. One more thing I want to mention. This is for base, right? For base, some more base I want to show you. Suppose NH4OH, that means basically ammonia. Ammonia is nothing but NH4OH. If you add water with this, then you will be getting NH4OH. So this will be getting having one OH minus, so N factor is 1. Suppose NaHCO3, sodium bicarbonate, it will also have N factor equal to 1, because total positive charge here is Na plus 1 positive charge. If you dissociate it, Na plus plus HCO3 minus. Okay, but for Na2CO3, this is also base, right? But you can solve it like in a salt. In salt, how I have taught you to solve, here 2 Na plus, so 2 positive charge, so it will be having N factor of 2. Okay, now redox system. Suppose in any reaction, redox system, in any redox system, N factor will be, for any redox system, mark my word, for any redox system, N factor will be number of electrons, nothing but number of electrons. Suppose for any redox process, Fe is getting converted to Fe3 plus. How many electrons have exchanged? We know iron has lost 3 electrons, right? So it is a 3 electron process. So here N factor will be 3. Suppose Fe2 plus to Fe3 plus. So here 1 electron is getting exchanged. So here N factor will be 1. A very typical example is from permanganatometry and dichromatometry. Permanganatometry. Permanganatometry is where MnO4 minus is used as oxidizing agent. What happens? For MnO4 minus, you have to calculate N factor. How will you calculate? For this kind of system, first you have to know that what is the fate of this metal. Here actually Mn is converted to Mn2 plus. Just you have to know MnO4 minus is converted to Mn2 plus. Just it. Next, everywhere the rule is same. Here is 4O. To counter, to balance this 4 oxygen, you have to add 4 water here, because 4 water will have 4 oxygen. But by adding 4 water, you have added extra 8 hydrogen. To balance that 8 hydrogen, you have to add 8 H plus. Okay. Now we have balanced the mass of both sides. So both sides there are 1 Mn, 4O and 8 H in both sides. So equation has balanced. But till now charge is not balanced. Here in the reactant side, this system has overall -1 charge, and this system has total +8 charge, isn't it? 1 H plus is +1, then 8 H plus is +8. This system has +2 charge, and this system has 0 charge. Now overall here is +7 charge, reactant side, but in overall product side this is +2 charge. Then if we add 5 electron here, 5 electron means 5 negative charge, so 5 negative plus 7 positive, that means overall +2. So in both side positive charge is thus balanced. So overall equation will be MnO4 minus plus 8H plus plus 5E. So how many electrons is involved? 5 electron is involved, so N factor is 5. Now one homework for you, one compound that is used in dichromatometry. Dichromatometry, the compound is dichromate, Cr2O7 double minus. It is converted to 2Cr3 plus. So calculate in the same way, and I'm telling you answer, N factor will be 6. Just calculate it. It is your homework. So I hope you have understood all the aspect of N factor. I have taught you each and everything about N factor. So I hope it's beneficial to you. Thank you.